Third class of chemistry in everyday life, starting with the topic cleansing agents. Cleansing agents are of two types: soaps and detergents. Soaps are sodium or potassium salts of long chain carboxylic acids. Sodium or potassium salts of long chain carboxylic acids. For example, stearic acid, oleic acid, palmitic acid. These are three examples of long chain carboxylic acids which are used in the making of soap. Now, manufacture of soap. How soap is prepared? Soaps are prepared by heating oils or fats with sodium hydroxide. When oils and fats are heated with sodium hydroxide, we get soap, and this reaction is called sponification reaction. Name of this reaction is sponification reaction. Now, taking one example, the soap prepared from the stearic acid. So this is a fat or oil or oil, long chain. See, C17H35, 17 carbons are there, so this is a long chain. When we add sodium hydroxide to this and heat this, then what will happen? The bond will break from here, CH2, CH, CH2. This part separates out from this, and then from sodium hydroxide, the OH will come and link with this part. So 3OH will come and link with this part. Plus these parts which will separate out now, there's no bond between these three. So these three will separate and they combine with the sodium of NaOH. This part COOH is a carboxylic acid, but now we have COONA. H is replaced by Na. So this is a sodium salt of carboxylic acid and higher carboxylic acid. Higher means carbon atoms are more. That means this one is a soap. And this byproduct which is formed in this reaction is also a useful compound called glycerol. This is called glycerol. And this reaction is known as sponification reaction. This soap is prepared from stearic acid. This is prepared from stearic acid. The formula for stearic acid is C17H35 COOH. C17H35. C17H35. So this is a soap prepared from stearic acid. Now, there's a mixture of soap and glycerol actually. There's a mixture of soap and glycerol here. To separate the soap from this glycerol, what we have to do now is add NaCl. When we add NaCl, the soap will come on the top part of the container, and from where we can separate it. Potassium soaps are soft to skin as compared to the sodium soaps. Next, after doing the manufacturing of soap, one question is here: why do soaps not work in hard water? Why soaps do not work in hard water? Hard water has calcium and magnesium salts. So when soap is added to this water, which has calcium and magnesium salts, then these calcium and magnesium ions combined with the soap. Like for example, this is a soap. When added to hard water, which has salts of calcium and magnesium, like calcium chloride. So this is from the water. So soap combines with these calcium and magnesium salts, C17H35COO. In place of Na, there will be calcium now. This has one valency, calcium has two valency. So when calcium is replacing this sodium with two valency, then this one will become C17H35COO whole twice Ca to balance the valencies. And plus this Na that comes out combines with the Cl, and there's formation of NaCl. Now soap has changed to this part, and this is insoluble in the form of precipitates. Since soap now is not dissolving in water, it is in the form of precipitates, it cannot do its cleansing action. This insoluble soap separates as scum. This insoluble soap in water separates as scum and is useless now as cleansing agent. So harms of using hard water. Harms of using hard water. These precipitates which are formed, the precipitates formed stick to the fiber. They stick to the fiber of the cloth as gummy mass, sticky mass. Second harm is hair washed with hard water looks dull. Why? Because of these sticky precipitates. So these are the harms of using hard water. After soaps, next topic is synthetic detergents. Detergents are long chain hydrocarbons of benzene, sulfonic acid, Now, what is benzene sulfonic acid? This is benzene, and in benzene, if we have SO3H group, SO3H group is sulfonic group. So this becomes benzene sulfonic acid. And if we have long chain attached here of hydrocarbons, then that benzene sulfonic acid will become a synthetic detergent. Advantages of using detergents. They can be used both in soft and hard water because they give foam even in hard water, because detergents do not combine with calcium and magnesium salts of hard water. So they remain dissolved in the water, and hence there is formation of foam which is required for the cleansing. Classification of detergents. Very important topic. It is of three types. First is anionic detergents. Anionic detergents. These are sodium salts of sulfonated long chain alcohols or hydrocarbons. Example: sodium salts of sulfonated long chain alcohol or hydrocarbon. I am taking long chain alcohol, CH3, CH2 whole 10, CH2OH, 1, 10 and 1, 10, 11, 12. 12 carbon atoms are there. So this is a long chain. OH is alcoholic group. So it's a long chain alcohol example. When this is reacted with sulfuric acid, then what will happen? This H is replaced by sulfonic group in sulfuric acid. See, sulfuric acid, H2SO4, can be written as OH SO3H. One O I am linking with this H, so this becomes OH. Now after removing one oxygen, this is SO3. That SO3 combines with one H left here, so this is SO3H. H2SO4. I am writing sulfuric acid like this. Now sulfuric acid, this OH links with this hydrogen and it will form water. And in place of this hydrogen, now this SO3H group will come here, and now it will become CH3, CH2 whole 10, CH2O, and now in place of H there is SO3H. Now this is called sulfonated long chain alcohol. In alcohol, now sulfonic group is there, so this becomes sulfonated long chain alcohol. Now for the sodium, this is now reacted with NaOH. This H comes out, combines with this OH, this formation of water, and in place of this H now this Na will come here, and this becomes CH3, CH2 whole 10, CH2O SO3 Na. Name of this detergent is sodium lauryl sulfate. Sodium lauryl sulfate. This is an example of anionic detergent, and this alcohol is lauryl alcohol. This is lauryl alcohol. See now, anionic detergents are sodium salts. See, there's sodium here. Sodium salts of sulfonated SO3H sulfonic group. Sulfonated long chain alcohols or hydrocarbons can be taken here in place of an alcohol. Now, why these are called anionic detergents? This is positive part in this is negative. The bigger part here is anionic, which does the cleansing action. Hence, these kind of detergents are known as anionic detergents. These detergents are called anionic detergents. Now, use of these anionic detergents. Most widely used detergents are the anionic. These are used for household work and in toothpaste. Second type of detergents are cationic detergents. Cationic detergents. These are quaternary ammonium salts of amines with acetates, chlorides or bromides as anions. Example, cetyl cationic detergents, quaternary ammonium salts of amines with acetates, chlorides or bromides as anions are cationic detergents. Example is cetyl trimethyl ammonium bromide. Its formula is now see, it's quaternary ammonium salt. What is quaternary ammonium salt of amine? This is N. NH3 is, NH2 is the amine group. NH2 is the amine group. And if we replace the hydrogen by the alkyl groups, then that will become your secondary or tertiary amines. Like here, N linking with the alkyl groups on four sides. When nitrogen links with alkyl groups on four sides, it is quaternary. Quaternary means four. On four sides there is an alkyl group. So quaternary ammonium salt. Ammonium is NH3 plus. So in this ammonium, these three hydrogens are replaced by an alkyl group. So alkyl groups are here. Quaternary means on four sides. This is a plus charge, quaternary ammonium salt of amine. Now to stabilize this charge, we need an anion. That anion can be acetate, chloride or bromide as anions. So quaternary ammonium salts, quaternary four side ammonium salts with bromide, chloride, acetates as anion are called cationic detergents. Now this is cetyl trimethyl ammonium bromide. Why this is called Cationic detergent, because a major part here, this cation, major part here is cation, which does the cleansing action. Use number 1 in hair conditioners, and second is it's germicidal in nature. It is germicidal in nature. But this is expensive. These kind of detergents are expensive, so their use is limited. These are the second type of detergents called cationic detergents. Now coming to the third type of detergents, these are non-ionic detergents. They do not contain any ion. For example, detergents formed from stearic acid and polyethylene glycol. Stearic acid, CH3, CH2 whole 16, COOH. 17 carbon atoms are here in this part, and then there is COOH group. This is stearic acid. When this is reacted with polyethylene glycol, this is the formula for polyethylene glycol. Poly means many. When the two are reacted, see this OH, and from here I am removing this H. Water is coming out from here, and the two parts combine with each other. CH3, CH2 whole 16, then is CO left here, and after the CO combines with this O of polyethylene glycol, continue CH2, CH2O whole N, CH2, CH2OH. This is an example of non-ionic detergent formed from stearic acid and polyethylene glycol. Use: liquid dishwashing detergents are non-ionic detergents. Now, disadvantage of using detergents. Advantage we have done that they can be used even if the water is hard. But disadvantage of using detergents: if in the making of detergents the hydrocarbon chain is highly branched. Remember, for making of detergents, if hydrocarbon chain is highly branched, then the bacteria cannot degrade them easily. Slow degradation of detergents leads to accumulation. So they will start collecting in the water bodies. Effluents containing such detergents reach the rivers, ponds, and remain in water and cause foaming in rivers, ponds, and streams, and their water gets polluted because these are not degraded. That is why they will accumulate and the water gets polluted. Now these days, the branching of the hydrocarbon chain is controlled and kept to the minimum. Unbranched chains can be biodegraded more easily and hence pollution is prevented. So, the detergents which will have more branching in the hydrocarbon chain, they cannot be degraded easily. So the branching of hydrocarbon chain is controlled. Minimum unbranched chains can be biodegraded more easily and hence pollution is prevented. One question. Label the hydrophilic and hydrophobic parts in the following compounds. In the following compounds, label hydrophilic and hydrophobic part. Now see in this example, start from left hand side till you will have carbon and hydrogen atoms only. That part is hydrophobic in nature. Now if some other atom is here, apart from carbon and hydrogen, from wherever you will have another atom, that part is hydrophilic in nature. This part having only carbon and hydrogen atoms. This is hydrophobic. When some other atom comes from there, the hydrophilic part starts. From there, the hydrophilic part starts. Next topic, the last topic of the chapter. Antioxidants in food. Antioxidants in food. These are the food additives. These are added to the food which help in food preservation. How they help in the food preservation? By retarding the action of oxygen on food. Oxygen cannot attack the food. These are more reactive towards oxygen than the food material which they are protecting. Example of antioxidants are BHT, BHA. BHT full form is butylated hydroxy toluene, and BHA is butylated hydroxy anisole. BHA in butter increases its shelf life from months to years. BHA and BHT with citric acid produce more effect. SO2 is an antioxidant for wine, beer, sugar syrups, and cut, peeled or dried fruits and vegetables. So this is about antioxidants in food.